Okay. See if we get the audio back tonight. All right, welcome back to the live stream. My name is Lance Rushing, and I'm a computer programmer. And tonight we're going to be looking at managing configuration and secrets in a web application written in Go. Really want to make sure the audio is working well before we start, so I'm going to check it real quick. Just a second. All right, welcome back to the live stream. My name is Lance Rushing, and I'm a computer programmer. And tonight we're going to be looking at managing configuration and secrets in a web application written in Go. Sounds like it's working. All right. Camera looks a little blurry from that side, but it is what it is. So I need to get this recording done. It's been 2 days. I've been wanting to do a podcast every day for 7 days, and then do a recap and see how that, or not a podcast, but a live stream, 7 days in a row. See how that goes, and it is hard. I have a lot of respect for the people who do this, and it's only been growing as I've been trying to solve these problems on my own. In fact, I think my camera's a little tilted wrong here. Let me see if I can fix that the right way. All right, good enough. Let's bring that back just a little bit here. Not quite sure how to fix that right now, but okay, we're just going to get this done. So last time we started writing a Go application and trying to create a bare bones skeleton server that's fully featured. That's the goal of this series, and that we can then use to build other projects with. The hope is for the future is we can make several videos and do different applications with it and deploy it different ways and just have a good baseline. So might as well record building that thing from scratch. So after reviewing, though, the last few episodes, I realized I had really bad audio, and the audio was just not up to par, and it was going to kill me in the long run. So don't want to have that. Originally, I'd been using the audio on just an inexpensive pair of headphones with the little microphone on them, connected to a 3.5 millimeter jack that was connected into the sound card of the computer. The headphones work great on the same computer when it's booted into Windows, but when booting into Linux, something with the motherboard sound card has a really high noise floor on it. Lots of noise sneaking through. As far as I can tell, it's probably in the ALSA layer. It just detects it as a generic HD card, and there might be some setting that's too high. Using the ALSA mixer, I was able to bring down the PCM and the mic boosting and get it to pretty acceptable levels, and I was hoping to run with that for a while, but every time I would then adjust the volume in any application, Pulse Audio would grab that and change all the settings back to where they were. So you'd be running the ALSA mixer in one place and the Pulse Audio mixer in the other, and adjusting Pulse Audio would adjust ALSA, and also you had more control, so I could get down the noise levels reasonably. Anyway, all that said, there might be something I can do, but right now the computer beat me, which is unusual for me, but I did spend 2 days just struggling with it, and I really want to get these podcasts going. I don't want it to be a stop, so I stopped by my local music store tonight, picked up a USB microphone, and so far it's been working good. Enough of the recap, enough of my sound problems, and hopefully things are only going to improve in the future. So this is only my third episode and second episode kind of in this series. So, all right. Well, tonight, really want to work on talking about configuration and talking about how configuration is a complicated part of the software developer's life, or it can be. Quite often, if you're using a off-the-shelf library like Rails or Django, it's going to have the way it thinks it should do things, and that's great. But we're trying to keep everything simple and not require the developer to go, find and do things more than one way. And configuration is, we're going to take this philosophy as we keep building this application up of, do things one way that works for, all your use cases or almost all your use cases. So inside configuration, quite often we have secrets like database connection strings, API tokens, things of that nature. And even though we call them configuration, they're really secrets. And once you introduce secrets into a system, sometimes your knee jerk will be to, well, I have configuration, which aren't secrets, things like maybe port numbers or paths to files in the system. And then there's secrets like tokens and database connection strings. But you manage in they're kind of the same thing. They're settings for your application that you're writing to work. So why not make them one thing? And we don't want to bring secrets into configuration because we want to keep them secret. So let's make everything a secret. And that way there's only one place that we have to go configure. There's only one place we have to manage, only one place we have to double check when problems arise. So, we're going to do that. Now, today, when we're going to build this, I'm still going to call it config, even though it's going to have secrets. Maybe, let's go ahead and change that. I'm going to change my mind on that. Let's rename this thing. What program am I in? There's the hotkey. No, should have 6. There it is. We'll call it secrets. Secrets. And I'm just putting the secrets file right here for example. And again, we wouldn't want to check this in. And because the applications we write don't exist in a vacuum typically, unless we're just writing them for testing. And by that, I mean, we're going to deploy this application somewhere. We're going to write this server. We're going to build up all this code with the hope of, sending it out there, getting it launched out into the wild and giving value to our employers or our customers. So those platforms that we're going to deploy it on, be it AWS or Google Cloud, Azure, DigitalOcean, Linode, they're going to typically have a secret management system in there. So the way you're going to manage your secrets are going to kind of be dependent on who you deploy with, who your hosting is going to be with. Or you can have a kind of a host agnostic system, something like HashiCorp's Vault, and secrets can go there. But no matter where your production secrets go, try to use the same mechanism for storage in your production system as you do for development, as you do for QA, as you do for testing. Therefore, you don't have, in development, we go get secrets over from our 1Password vault, and that's locally installed. But for production, we use, let's say you're using Google Cloud, you can use Google Cloud's Secret Manager. So, make each system work the same. So, each environmental level work the same. How I've done it in the past is, developers have credentialed accounts into G-Cloud, not for the production systems or the production projects, but for the developer projects. And quite often we have developer APIs that are available for systems we might be writing our program against. So writing a program that has another API that's also run by the organization, and we want to be able to get that, make that available for the developer. So the developer has credentials to make connections, socket connections. Maybe there's a developer database or caches or things like that. So the developers are going to be credentialed into the environment already. Might as well use that environment to provide the secrets for the development process. All right. You could also use something like, let's say you don't have a environment, but you want to build up secrets right now, but you still want to keep them safe. You could use something like GitCrypt, which is a extension for Git. It works well. You have to maintain your public-private keys between people in the trust pool, so when developers come on, you can add them to the key. You have to generate a key pair and get that added to. And so there's a little bit of more kind of manual management, but it does remove this third-party dependency. But you're going to have a third-party dependency. This code's going to go somewhere once you write it. So just use the same place for that. And after you've, working on your secrets, whatever it might be, some service API key here in this awful name, validate. And that's what I got stuck on last time, and that episode was running long anyway, so time to cut it off. But if someone misspells, let's say we were supposed to have foo as some, we have some foo token, and it's supposed to be, ABC123, but they misspell foo token, and some of they didn't get the message correct, and they spell it like that. We want to not accept that secrets, and it sounds obvious. Yeah, of course. But I've seen many systems where is a lot of junk, unused values, values that were spelled wrong that are kept in there, and there are bugs in the system or unexpected behavior because the configuration of the platform is incorrect. So always validate, especially for mistaken things. And that brings me up to another point of, if you always validate and if you don't accept defaults, that anything that your system expects to know about in terms of configuration is in the configuration. And there's a lot of movement towards saying defaults in software, and that's really helpful if you're a consumer of a piece of software. For example, if I'm going to run a Postgres database and I don't specify the port, and I don't think it requires the port to be specified, I'm going to assume it's going to be on 5432, or if it's MySQL, it's 3306 for the port number. But that's useful when we're consuming a piece of software, or I'm going to be using a service that I expect it to have a certain amount of default behavior, or it came with configurations already as part of the package which define all that default behavior, and that's the default configuration in the config. But quite often the configs don't outline every option. You have to go read the manual, and then now have to go look around to see what possible configs are. But this is but I'm trying to make the distinction is we're writing software ourselves that we're not just the consumers of, but we're the creators and we're the maintainers. We're the ones who have to edit it. We're the ones who have to debug it when it goes wrong. And by not using defaults anywhere, you are making a contract, explicit contract that I need to know all this information before I proceed. And it might be obvious information, maybe, or you might think it's obvious, but someone else won't think it's obvious, perhaps in the future. So no defaults. So if a token is missing or a key is missing out of your secret file, that should, throw an error of some sort. If you're having a continuous deployment system and the next version of the software doesn't get some value it needs, not having that deployment succeed, right? If you're doing a blue-green deployment and green's running and you're trying to deploy blue, but blue's not coming up, there should be produce an error like blue is missing some type of value, and get that fixed, and then deploy blue and have it roll out. So that said, let's actually fix the code here to check. And I was trying to do it last time and it was getting late. I mean, it's late right now. It's almost 4 a.m. here, but it's been a long day, and trying to get the audio problem sorted out has not been fun for me. But I really wanted to get this stream out and just get it done. So anyway, we'd been loading the config, and I was really trying to determine, with this YAML Marshal, I believe there's a way, like some option or something, to validate any unknown values. And so, being this is open source software and this ID is pretty good here, I can click right into the Marshal function inside the code here, and I click this button here, which will take me to it in this file tree. And I realize I'm in this YAML v3 version, and I can see all the files now. Let's see here. What could it be called? If you notice, I've already looked for it earlier, but it's strict. And I noticed there was some tests, and it's a well-tested package. So there's some strict tests for decoding. Okay. Well, this looks like it's going to set up a bunch of table-driven tests here. Yeah. Okay. Good. All right. Okay, here we go. If it's not unique, it's just calling unmarshal and make sure there's no errors. Usually it looks like testify or whatever this assert is. What assert is this? This is their own helper. Cute. But new decoder, known field, items known. This is what we're looking for. Reflect value of type. I don't care about that so much because we're not using reflection. T, yeah. Get the new value out of T for that type. Yeah, let's just steal this bit of code here. Borrow, not steal, but borrow. And we're going to, when we unmarshal or marshal, we're going to, there's a new decoder. And unmarshal. Yeah, since a new decoder parses the in, destroys. Looks like we just have to add the strict perhaps here. So haven't tried this yet. All right, so we're doing an inline bytes reader here for, and this was doing for the test where they had a buffer, but I've got my bytes from the file already here in this variable B. So give me a new decoder for item B, and known fields enable true. Okay, so here's a true false value, sets into the known fields onto the struct. All right, so just set known fields only. And now we're going to decode. It doesn't like that. Look at that. What is this? This type IO reader does not implement IO reader. Some methods are missing. B does not implement IO reader. Oh, that's interesting. I'll figure that out in a second. And then we're going to decode this onto the config. And we'll get the error and we'll check the error. After we take care of this bytes error. So is a type IO. It's a new decoder wants an IO reader. So I need an IO reader for a file. Well, it is late, getting close to early, so I'm just going to search for it. So IO reader for a file. I'll go in the front. Create an IO reader from a local file. Ooh, that sounds pretty simple. IO reader is os.file nil. os.open returns a file. Return value of this implements IO reader interface. Oh, do I need to return a byte to this thing? Pointer? No. I mean, share? No. It's early. I'm just guessing. File os.open. Give me a file new. Oh, buff IO new reader. Okay. I might have had that just out of curiosity back over in their test. Bytes new buffer. Read file here is by array. And this new buffer. It's we want to run that byte buffer. Let's just go ahead and that's what I love about these tests. I'll just steal it from there. Borrow. Look at that. No more. Code looks happy, except for this error here, which I've already set here. So, looks like I can probably just do that and do that. And Just messing around with some things here. So new decoder, decode. If it fails, we're going to fatal, which will stop the application. I'm going to output the bytes of the YAML for some reason, and then I don't want to return. Oh. Guess we'll return L. Because we're not going to return the error here. We are going to die. Let's just see if this works. Undefined variable D. Oh. B. B for bytes. There we go. Could not read from config.yaml. That's right. I renamed it to secret. Secrets. Yay. There's my YAML file. I go to the local host here. My key is test123. All right. Now let's see if we can break it. Foo bar, save, quit, reload. Hey, foo was not found in main.conf. Excellent. And let's go look at our config here. And we have this conf. So, and this is maybe configuration. And right now it's in the main project. This will get moved to lib eventually. And we're not going to commit secrets, so let's go ahead and add that to get ignored just in case. Echo secrets, pop that into get ignore. All right. And we should add some tests for these, but again, it's now 4 a.m. in the morning, and I am tired, and I'm glad to get this up and shared with you. We'll add some more validation next time, and actually maybe start using this file to put some database connections in. So as always, let's finish off with a little git commit. I'm using git cola because it is late and I just need to read what I'm doing. Oh yeah, I moved really, did I commit config? I did commit config. Whoa. How to remove a file from git? Well, I think it was my last commit, so I'm just going to amend my last commit. I'm gonna cheat. And I haven't pushed this up anywhere yet either, so git ignore secrets, and that looks like a good commit. So add configuration commit. All right. Now that might be a good topic for the future too. What happens when you put bad things inside your repos? Let's do some planning topics here. Yeah, I did that. Got that elsewhere. How to fix bad commits in Git. Maybe also like remove secrets. If you're wondering what it, and yeah, I'm not saying I've had to do that before, but I'm saying I know how to do it. And usually my bad fixes are someone's committed a large PDF or something strange into Git, and it just needs to be removed. It happens, but that's why we have systems like Git and version control to make our lives easier. All right, well, thank you so much again for, if you're sticking around still, hanging out with me this early morning and getting this done. It's time for me to go to sleep, and hopefully we will keep building on this in the future. All right, have a good night, and I'll see you soon.